you either you've either got a machine sitting in your workshop that you just want to connect to FeatureCAM and want to use it for simulation, or you just designed your own machine in SolidWorks or Inventor. You can add import to FeatureCAM and add to your machine simulation to avoid collision. Now, if you got your physical machine, obviously you have to reverse engineer it and either in SolidWorks or Inventor, and then you can add to FeatureCAM. But if you have already designed your assembly, your router, then you can easily just add it to FeatureCAM, and this is what I'm going to show basically. So I've got this would be the original router, the version of this what we built, and this is not the full design. This is the full design, but this is not what you should use and you should add to FeatureCAM. It makes things complicated. I've got lots of assemblies, parts, solids constrained, and it's just no need for that. It makes heavy. It makes FeatureCAM slow. So therefore, I created a simplified version of it, and this is that you can see. It's exactly the same machine, but what I did, I just added bumpers to Z, to Y, and this could be useful when it comes to simulation. Obviously FeatureCAM is not going to see your limit switches, so this the easiest way, if you just add some bumpers to that. I added here, up there, this one is wider than normally, and then once you finish this, you can just simply measure your travel distance. Each axis is going to travel. This is what basically I measured, because you are going to need this data. So now I've got a Inventor assembly file that I'm going to import into FeatureCAM. Before I do that, when you start FeatureCAM, you have to choose machine design. You have to choose your units. Obviously, it's either inch or metric, or inch or millimeter. It's up to you, imperial, and then you arrive to the screen. You should see this machine design tab, and when you see that, then you are at the right place. You just have to click File, Import, and machine design. I'm going to choose this Inventor Start. You click Next. Now you have to tell FeatureCAM the orientation of your machine, but this is where you can double check. Z points up, X to the right, Y to the back, and this is all good. So unless it's different for you, you have to change this and align using those settings. I just click Next. I don't want to rotate anything, and just finish it. So that's it. You are there now. You what you can see here is this is the called words coordinate system of FeatureCAM, which is here. You can't move this, so this is a reference point that you could use, and you can make other coordinate systems, origins, and all points related to this point, which is the words coordinate system of FeatureCAM. And this is a machine file that you can use, you can save, you know, something goes wrong, you can go back, you can edit, and for that, for easier identification, you just you can rename these solids which are part of your assembly. For my assembly, I'm going to rename solid as a base. So it's going to be y-axis. It's going to be x-axis. So it's going to be my spindle. Top table. Once we've done this, we have to add, we have to tell FeatureCAM where your axes are going to move, and for that I go to this movement, and you have to specify solids that move, which direction they move to. And mine, I'm going to choose spindle, which is Z, and for this setup I choose plus data Z. Each time you have to click apply, and then I'm going to choose X, which is plus delta X, and then I choose Y, apply. Okay. Now we have to tell FeatureCAM our machine's limits, and so you see these fields are blanked out. It's just grayed out. You have to first choose spindle, which is Z. You just tick this box. So this is how FeatureCAM knows that Z, and then you are free to add your numbers. For my machine, I have to add here minus 350, 0, and minus 140. This is when you import your machine. After you see this machine design file, then you usually see position of axis, how you saved the position that you saved in Inventor or SolidWorks before import. So it's better for you and FeatureCAM, I think, if you align your machine, move your machine to the position where would be the machine's home position. So this would be the home position for my machine, and for that, the position where spindle sits, that right now is minus 140. That's why I choose minus 140. But you are going to have to play with these numbers. It's going to take time. It's not just you figure out numbers, you measure it, and you just throw it in, and that's gonna be fine. No, that's not gonna be fine. Here you are going to definitely spend some time, depending on what machine and what setup you got. So I apply for Z. Here you can get error messages, and then if you got some warnings, then you may choose the wrong direction for your machine, or if you got warnings, not just you might have chosen the wrong direction, plus or minus, but it also could be that you use positive number and you may need to add negative number, or you may need to add here 0 and here should be positive number or negative number. It's really depending on what what machine you built or designed. So now Z is okay. X for the limits are minus 786 and 0 and 0. That's currently the position and limits, how you can see right now. So I choose Y and just ignore Z here because obviously it's related, and that's why it gives you an option. But minus 430, 0 and minus 5, because I added just 5mm there from the limit, and click OK. Now we specified the movements, directions, and specified the limits of our machine. Now we have to specify the parent-child relationships within our axes and components in assembly, and here you will be able to see changes. This is this one is going to show this tree, the hierarchy of the machine, and this is how you can add it. So which component drives which side, basically, and for my machine I have to choose machine and base, but this one is not set yet and I can't apply, but this should be okay, and it's not there, so we have to go back to this setting again. So I choose top table, apply. As you can see, it's added here to this tree, and then I can go back now, base, and apply again, and then it turns up over there. So base is parent of my y-axis, and then y-axis is parent of x, and x, this is okay, x is parent of my spindle. Okay, and if you can see it here, what happened. Okay. Now, as I mentioned earlier, so this is our origin of FeatureCAM. Now we have to specify a user coordinate system for our stock, where our stock is going to be located on this router, on the tabletop, let's say. Now we can't just tell, okay, let's put it there. You have to for each point you have to you have to make a new user coordinate system. So before we tell where to put that solid, that stock, you have to add a coordinate system to attach it to. So this is what we are going to do, and you don't do it there. You have to go to home, user coordinate system, and just ignore this setting. You have to create new, and you can just name it. Let's say it's going to be stock. So this coordinate system, so here you can see the stock. This is original stock of FeatureCAM. This is what you are going to copy and move. So you click on that, and first just click OK. When you do that, then FeatureCAM is going to know that you just generated a copy of this stock. So it's going to know that that's also a stock position, because this is what you copied from. So click OK, and once you did it, it just made a copy. So now this is yours. This is not the original one. I can show you why. You can. There are many coordinate system on your in this environment, but by this drop down you can always choose which one to show. So now it's the same, but because it's the same location, obviously it doesn't move, and So we are going to move this now. And to do that, we are going to go to Align, and FeatureCAM is going to offer you, several options. They may work okay for other setups, but for my setup it didn't quite work well. It's quite difficult. Let's say 3 point to pick 3 points here. It's really difficult because it just doesn't pick up. It doesn't pick the points up. So what I did, and I found it easier to find the surface where I want to place this. I want to move this origin to, and I choose a surface, and now I'm going to pick a surface, which is going to be this. No, over there. Okay, now it found this face, and now you have to pick a point on the surface. You can only choose a point. You see that green cross, only that. You can't just, you can click there, but you can only click on the, if you click next to it, it's not going to accept it. So this seems to be the middle. Click on this. Okay, now we found the surface. Otherwise you would get the warning that you didn't hit the target, let's say. So now we found the surface. So this is going to move there once you click finish. It's there. Now this is not quite right. It's not quite right because it doesn't point to the right location, the right direction. So X should really point to the right, Y should really point up, and but so far this is the easiest way. So you can just click on Align, and no, not Align, hang on, just Rotate, and we are going to rotate this 90 degrees around Z axis. And I'm going to do that like just 90. That's it. And you don't have to save anything. It's going to save itself. Once you close the window, it's going to remain there. Now our stock location is set. Now we created this coordinate system for stock. That's not enough. Now we have to tell FeatureCAM that this is the coordinate system that you have to use for stock, and to do that you have to go to Machine Design, Topmost Table, and Existing User Coordinate System, and choose that we just created. Okay, hey buddy, put it there, and you see it's red already, and apply. Now FeatureCAM is going to know, okay, that's gonna be the place. And the next move, now we have to tell FeatureCAM, we have to tell FeatureCAM where we want to where is our tool located. Our Colette, our tool, it's located there, but FeatureCAM doesn't know about this. So just like, again, you can't just put the stock there. You have to make a user coordinate system over there, and to do that you have to go back home, user coordinate system, just ignore this, doesn't matter. And now we add that spindle. Okay, that's gonna be the location. Now you don't click on that. That's different setting now. Create and go to alignment wizard. Click on that, and it asks you to pick again surface. We choose that one. I'm gonna have to go there, and then we are there. Click OK. It found the face. You see arrows pointing again wrong direction, so that it points to the left. That's one X should point to the right. That one points towards us. That's not right. You can't just click, tick this flip direction, because that would result the tool would stick inside the spindle, not out, and that's not the right thing. So this is flip direction is not what you are looking for when you want to change direction again. You just click OK and you make sure you choose spindle here, and let's edit, align it again. And you can do the same thing, rotate this, and let's say we are going to rotate it 180, and that's it. Now it points to the right direction, so X there, Y there. But you can still adjust this. Let's say I'm going to align it, or not align it, translate. Then you can move, and you can say move this coordinate system -5 millimeter, which is down, and it goes down. And now you see it's obviously it was inside solid. Click OK. Now we told FeatureCAM where the spindle coordinate system is, spindle's coordinate system. Now we have to tell FeatureCAM that this is the coordinate system where we want to place our tool. So now we are going to go back to machine design, add to location, and then set user coordinate spindle, and then the solid holds the tool as the milling spindle. And now back again, and we are done. Apply. OK. We are basically finished our machine. Obviously we have to save it first, because we haven't saved it, and I'm going to do that. It's going to be start. That's gonna be the name. Okay, once you've done everything right, you should be able to jog your machine, and here you can move it, and these are the numbers that you specified in the movements menu over here. Yeah, and if you choose a wrong direction, then when you try to jog your machine, it may go outside of the whole assembly. So then that's why you have to play with these numbers. And why I added these bumpers there, there is a bumper, there is a bumper, and there is a bumper. This is when you go to jog machine, so we test x-axis moves just fine, but when we go to y-axis, then this is what happens. Goes there, that is okay, go back, bomb, it hits this bumper, and that basically collides there. Now you have to play with the numbers again, and then find the right setting for your design, but you can avoid this. That is this exactly what's missing there. And let's move this back and move it down and up. Now if you see one mistake could be what I've done several times, that I didn't pay attention. Hang on. Oh, no, it's there. Okay, that's fine. So when you start, let's say you want to jog your machine, and you would notice that some parts just disappear from your assembly. You just don't see them, or you start machine simulation, when you simulate some process or job, and during simulation you don't see parts that you actually added to your machine. Then the reason for that is that you haven't set properly your parent-child relationships, so that you miss something, or or you add it to the wrong place, wrong relation. And then when you start jogging your machine, it just disappears. It disappears. So far, this is where we are now. Let's see how we put some stock onto this, and how this machine operates. And to do that, okay, I saved it. I'm going to open some file that I've created in Inventor, which is this. Now, this is the alignment wizard, and this usually is not ticked, but it's quite useful to tick it because that would be your next move anyway. So I ticked it. For me, that's okay if I just click next, and it asks you if this coordinates origin it points to the right direction. So it's up to you. So you have to decide how you want to place this on the tabletop. Let's say this is the direction that I want. I want X, Y there, and Z up there. That should be. And this is how it is currently. Now, obviously, we have to change this. So what I say, I'm going to. So hang on, I'm going to show you which setting. So you have to pick a surface and say perpendicular. So this is what I choose. You have to click on, and it points, perpendicular. That is Z, points up. Okay, that's fine. And now, again, I want, let's say, X-axis to point to the right. So click next, and it's just easy. It asks you just to rotate around Z, and this is what I want. I'm going to click on this. Okay, Z points there, Y there. Next block. Okay, now it asks you for your stock dimensions that you want to use. It's up to you what stock you've got that you want to use for this job. For this tutorial, it's easier. Just choose this one and add extra stock size. I added 3 millimeters to each side, and then you can see there. And now you can confirm. Now you don't see origin yet. Now you have to choose where is your start point, and currently somewhere here. Oh, it's so you have to change this. So you got several options. These options also related to the stock user coordinate system. The location that you placed on your machine design on the tabletop. So if you put it there, then underneath that stock, that is going to be the center of your table. So basically it's going to be off the center, below. I don't like this. Because sometimes when the part is too big, then it might be out of limits of the machine. So it's quite useful if you just put in the center, and it's there, and that's going to sit right also in the center of the stock location that you defined in machine design. And you can see that there is the 3 millimeter. It's there. It sits right there. So that's okay with me. You click on next. No, you don't want that. Use FeatureCAM to recognize the host later. Finish. And now, because you ticked automatic feature recognition box when we started this dialog, then obviously it starts immediately. So you have to choose solid, which one you want, and then you click next, and FeatureCAM is going to find everything on your solid, and that's it. Finish. Now we open the part. Let's say you never opened your your machine design yet. So this is going to be the first time you want to use your machine design to run this job. Then you have to tell FeatureCAM, or rather you have to tell this setup, this job, for this part, which machine design you want to use this for simulation and to generate NC G code. And you can do that two ways. One is here, setup, properties, simulation, and here you have to opt that option, and just browse the MD file that we just made, this 3x whatever you call your machine file. And the other option, it's easier here. You can also see what machine file you use with this setup. Here you can see you want to change this, click on this same window pops up. Just want to confirm again. And start. This is what we just created. Okay, but it's there. It was there, and this is the post processor you want to use. Plenty of settings. You still have to play with this, but this is not about settings now. We apply. Okay, so we use our new machine, this post processor Mac free, and now you want to run your simulation and see how your machine is, or if there is any collision using your design. And to do that, you have to go down simulation mode and machine, and then it's going to turn on, and you want to start this simulation. Let's see what happens. And nothing happens, of course, because just like always, some problems. You click on OK, and let's see what happened here. You click on this results, op list, automatic ordering. Usually I tick, and here you can see that for these buses there is no tool specified. So you have to specify. It's you can do many ways. This is the easiest, for this job. Just click tools, and what I choose is flatten mill, and I choose 14 millimeter apply. So there is a warning, but because FeatureCAM is not going to happy, and obviously you are not going to be happy with the quality of the cut, or you may miss something. It misses something that it's not gonna either probably look the same what you designed file, but there is a warning. It gives you a it let you go, but that's definitely a warning you have to deal with. We still have this, and we choose tool again, flatten mill. Let's see, 18 apply. That one is okay, no complaints. Again, tool, flatten mill, 18 apply. Okay, seems okay now. Let's see. Oh, it's too fast. Let's slow it down. So this is the machine we just added. And you're going to see when collision detection comes in place in a minute. I have to speed this up a little bit. That's it. It warns you something happened. Let's see what happened. There is obviously there is a collision. The tool is the length of the tool suitable for this job. But yeah, this is, I just wanted to show you, how you can use your machine design, how you can build up, and how you can make this work. And after there is plenty of settings you have to change, you want to modify, you want to set up your tool crib. It's up to you, but I hope this video is going to help everyone.